Today we are doing lessons 5.3 and 5.4, writing and solving proportions. Today's I can statements, I can use equations to write proportions. I can use a point on a graph to write and solve a proportion. And I can use different strategies to solve proportions. So here are some properties of proportional relationships. Some of these we've already discussed. So one quantity is a multiple of the other. That means there's a multiplication relationship between them. If the first quantity is a 0, the other quantity is a 0. If you double one quantity, the other quantity doubles as well. And then cross products of any two ratios are equal if they are proportional. So our key idea here is for solving proportions, we're going to look at a bunch of different strategies. So using mental math, that's really the 5.3 strategy. And then in 5.4, we're going to look at multiplication, property of equality, and cross products property, and talk about which problems apply themselves better to multiplication or cross products. And then we have some other strategies here. Whoa, clicked out of the thing. There we go. Using a tape diagram, using a ratio table, and using a unit rate. All right, so here's our first type of problem. It says write a proportion to find how many points a student needs to score on the test to get a given score. Test is worth 50 points, and the test score is 75%. So we need to start by writing that 75% as a fraction or as a ratio. You can think about it either way. 75% means 75 out of 100. Percent means out of 100. Okay, and then the test is worth 50 points. So here for percent, this is a part out of a whole, 75 out of 100. The whole test is 50 points. So that's going to go on the bottom. And then we don't know how many points you need in order to have a 75%. So that's our proportion. X is to 50 as 75 is to 100. It did not say to solve on this one, so we don't need to solve it. They just wanted us to write the proportion. All right, so let's take a look at this image of some proportions. So here we have 5 over 15 and we have 10 over 30. They're on a balance here, and that's because things that are proportional rates, work like equivalent fractions. They're equal to each other. The numbers look different, but they're still equal in value. We could say 5 times 2 is 10, and 15 times 2 is 30. It's a side-to-side pattern. Or we could say 5 times 3 is 15, and 10 times 3 is 30. That's an up and down pattern. And we can use side-to-side multiplication and up and down multiplication to help us when we are solving proportions. So if we got rid of this 10 and we put in an x, we have 5 is to 15 as x is to 30. And then we can use those multiples to help us find what x is. So I could say I know 15 times 2 equals 30. So I'm going to do 5 times 2, which equals 10. So we get x equals 10. So that's how we can solve for x using multiples. And again, you can look up and down too. Okay, I know 15 divided by 3 is 5, so 30 divided by 3 gives us our answer for x. Sometimes there's not an easy multiplication relationship. You cannot multiply both the numerator and the denominator by the same whole number like we did in that last one. So when that happens, we use cross products. We cross multiply. What that means is we look at the diagonals. And we know that the diagonals, the multiplication, is going to be equal to each other if it's a proportion. We looked at that, I think, in 5.1 or 5.2. So now we are using the fact that we know cross products are equal to set up an equation that we can use to find that value of the variable. So I have 6 times 14 equals 21. times x. All right, let's see. 21 times x is just 21x. 6 times 14, I'm going to do off to the side here. 4 times 6 is 24. 6 times 2 is 6, plus 2 is 8, so 84 equals 21x. And then to get the x by itself, we have to divide by 21. 84 divided by 21 is 4. So that strategy is called cross products. All right, let's try some more cross product problems. All right, so I have 4x equals 3 times 6. And that means 4x equals 18. Then we need to divide by 4. So I'm going to do 18 divided by 4 off to the side. 4 goes into 18 4 times. 4 times 4 is 16. We have 2 left over. Let's see, I'll do a decimal. Bring down that 0. 4 goes into 25 times. So my answer is x equals 4 and a half. All right. Let's take a look at this one. If we're going to do cross products, multiply on those diagonals. So we have 4 times r, which is 4r. Then we have 12 times 10, which is 120. We need to divide by 4. Then we get r equals 30. Now we could have also done a multiplication up and down pattern. There isn't one side to side. You can't do 4 times something to get 10. That's a whole number. But you can say 4 times 3 is 12. So I could take 10 times 3 to get my answer. So while this one doesn't have a whole number side to side multiplication pattern, it does have a whole number up and down multiplication pattern. Okay, go ahead and pause the video and try these next 2 on your own. All right, let's check our answers. No multiplication patterns with whole numbers side to side or up to down. So let's go ahead and do cross products. 3 times 9 is 27. 4 times y is 4y. We need to divide both sides by 4. Do my division over here. 27 divided by 4. 4 goes into 27 6 times. 4 times 6 is 24. We get a 3. I'm going to make this one a mixed number. 6 and 3/4. Okay. Let's take a look at this next one. Again, no side-to-side multiplication, no up and down multiplication pattern. So we're going to do cross products. 6 times z is 6z. 8 times 5 is 40. We need to divide by the number with the variable. Z equals, then I need to do 40 divided by 6. 6 goes in 6 times. We subtract to get 4. 6 and 4th 6, which simplifies to 6 and 2/3. If you're writing an answer that is a fraction or a mixed number, you do need to make sure that your final answer is in simplest form. All right, let's take a look at this story problem. It says the graph shows the toll y due on a turnpike for driving X miles. Your toll is $7.50. How many kilometers did you drive? And then it says there are approximately 1 and 1600 kilometers in a mile. This information is half of my proportion. 1 and 1600 kilometers for 1 mile. Okay. Now I need to know how many miles, x miles. So the x is going to go on the bottom. When you're doing proportions for word problems, you want to make sure your labels match up. Miles on the bottom, kilometers on the top. And then to get the number of kilometers that we drove, we have to use this $7.50. Bring it over here. If I paid $7.50, that means I drove 100 miles. Ooh, let's see. I actually, it says X miles, but my number of miles actually here is 100. I need to erase what I wrote here. An eraser? Nope. There we go. Okay. All right. How many kilometers? That's my variable. I should have gone back and read the question a little bit more closely. X kilometers. And then I have 100 miles. The X above here, total Y and X, that means X axis and Y axis. Okay, so I want to know how many kilometers. That's my variable. For $7.50, it was 100 miles. All right. So we can do a side-to-side pattern. We can do cross products. I'm going to do a side-to-side multiplication pattern on this one. I know that 1 mile times 100 equals 100 miles. So I'm going to do 1 and 1600 kilometers times 100 to figure out how many kilometers I actually drove. So when I multiply 1 and 1600ths, when you multiply by 100, it's like moving that decimal 2 places over to the right. So 116 kilometers is going to be my answer on that one. All right, let's use a ratio table for this problem. So we're using a ratio table to help us think about this proportional situation. 1 pack of gum has 18 sticks. So we're going to fill out this table to show how many sticks of gum in different amount of packs. So 1 pack is 18, 2 packs is 36. One way to get that answer, and there are lots of different ways to do our patterns and ratio tables. But I did that. I did times 2. Okay, I know it's 2 times 2 to get to 4, so I'm going to go ahead and do a times 2 pattern again. And I know 36 times 2 is 72. I could have also done 1 times 4 and 18 times 4 to get to that answer. All right, 4 to 8. Again, I'm doubling. So I can double here as well. 72 times 2 is going to be 144. All right. Now I no longer have an easy times 2 times 2. My pattern is changing a little bit. So I'm going to go back to my original one. To 1 to 10 is like times 10. So I'm going to take this one. I'll go all the way over here. Times 10. 18 times 10 is 180. And then to get to 9. 18 times 9, if I'm doing it in my head, it's a little tricky. But I could also say I could subtract 1 pack. So 10 packs, I'm taking 1 pack away. That's 19, so I would have to take away 18 sticks of gum. And I know that's going to give me 162. So that's how ratio tables work, that we can use these same multiplication patterns side to side. Could have done 1 times 18, 4 times 18, 8 times 18. And then I can also use that ratio to add or subtract as long as I'm keeping adding or subtracting within that same ratio. So we took away 1 pack of gum, so we took away 18 sticks as well. All right, let's look at a proportional problem that makes sense to use a taper diagram for. So it says a punch recipe calls for 5 parts ginger ale to 2 parts orange juice. If you need to make 28 cups for a party, how much of each ingredient is needed? So I have 5 boxes for my 5 parts ginger ale. I have 2 boxes for my 2 parts orange juice. So all together, I have 7 parts. I got that from adding my numbers of boxes. 5 boxes, 2 boxes, 7 parts. I need to figure out how many cups will go in each one of these. I need 28 cups of liquid split into 7 parts. So I'm going to do 28 divided by 7. That equals 4. So that means each one of these parts is worth 4 cups. Counted my total number of parts, and then I divided the amount of liquid, 28 cups, into 7 parts so I could see how much goes for each. Okay, how much of each ingredient is needed? Well, let's add 4. 1, 2, 3, 4, 5 boxes. 4 times 5. I'm going to need 20 cups of ginger ale, and then I'm going to need 8 cups of orange juice. All right, let's take a look at how we could solve a proportion with a unit rate. If 2 pounds of cheese costs $16, how much will 9 pounds cost? 2 over 16 and 9 over x. It's a little hard for me to do that in my head, but if I make it into a unit rate, it becomes a much simpler problem. So if I take 2 pounds and I divide that by 2 just to figure out the unit cost, how much for 1? Well, I can divide here as well. Remember, proportional, we can do multiplication or division patterns from side to side. Okay, so that means 1 pound's going to be $8. And now that I know that, then I can multiply by 9 on the top and 9 on the bottom to get $72 for 9 pounds. Setting up proportions for story problems. Make sure to keep the same labels lined up in the proportion. Same labels in the numerator, same labels in the denominator. All right, J&A department store is selling 3 pairs of children's socks for $5. Mrs. Wagner wants to buy a dozen pair of socks. How much will this cost? So I'm going to start with the information that they give me in that first sentence. Throw 3 pairs, and that's going to be $5. Now I could have put the $5 on top. I just chose to keep them in the order that they were here. She wants to buy a dozen. A dozen is 12. And we don't know the cost. X dollars. Now I could do cross products if we want, but I see a side-to-side multiplication pattern. Anytime I do that, I like to use it just because I think it's fast. All right, 3 times 4 is 12. I'm buying 4 times more socks. So I'm going to have 4 times more cost. 5 times 4 is 20. So how much will it cost? $20. All right, here's the problem to try on your own. Solve the problem in as many ways as you can. If 2 caterpillars eat 5 leaves, how many leaves will 30 caterpillars eat? Go ahead and pause the video and try this in as many ways as you can. Okay, so let's solve it. One way to do it is to write a proportion. So 2 caterpillars for 5 leaves. And we want to know for 30 caterpillars how many leaves. going to use that one. So now that I have my proportion, one way to solve it would be to use multiplication. 2 times 15 equals 30. I have 15 times more caterpillars. So I'm going to do 5 times 15. Five times 5 is 25. 5 times 1 is 5 plus 2 is 7. So I get leaves equals 75. Another way to do it, same proportion. 2 caterpillars, 5 leaves, 30 caterpillars. How many leaves? We could have done cross products. So 2 times x, or L, I guess I'll use L since I have L there. And then 30 times 5 is 150. And we divide by 2. And we get 75. All right, go ahead and pause and try this problem. All right, it says a cookie recipe calls for 3 cups of chocolate chips and 2 cups of peanut butter. How many cups of chocolate chips will be needed if 9 cups of peanut butter are used? All right, so I have 3 cups chocolate chips for 2 cups peanut butter. And I want to know how many, I'm going to call it X, chocolate chips for 9 cups of peanut butter. All right, so let's see. I could do cross products on this one. 2x equals 27 divided by 2. X equals 13.5 cups chocolate chips. All right, let's look at this last one. To make perfect purple paint, mix 2 cups of blue paint with 3 cups of red paint. You want to make 20 cups of perfect purple paint. How many of each color do you need? Go ahead and pause the video and try this one. All right. One way to do this is a tape diagram. 2 cups, I'm going to do 2 boxes. And then for red, 3 cups, 3 boxes. And then we need to do 20 divided by 1, 2, 3, 4, 5. There are 5 sections. Equals 4. That means 4 cups in each one. So when I add there, I get 8 cups blue and 12 cups red. Could have also used a ratio table on this one. Blue, red, purple. Two cups blue, 3, whoa, I don't know where that C came from, my goodness. Okay, 3 cups red. I add those together. One batch makes 5 cups of purple paint. And then we want to make 20 cups total. So on my ratio table, I'm going to have to multiply everything by 4. So 2 times 4 is 8. 3 times 4 is 12. And yes, when I add 8 and 12, I get 20. 8 cups blue, 12 cups red is my answer. Either way I do it.